Hello everyone and welcome back to DevPortal. In today's video, we are going to start a new series on the most transformative addition in Java, the StreamAPI. The StreamAPI introduced in Java 8 and has completely changed the way we work with the collections, allowing for more concise, readable and efficient code. So let's dive in and see what makes the StreamAPI so powerful. First, let's start by understanding what the StreamAPI is and why it is so important. At its core, the StreamAPI provides a way to process collections such as list, set or map in the functional and declarative style. Instead of writing loops to iterate over collections, we can use stream to specify what we want to achieve without dealing how to do it. Think of a stream as a pipeline where data flows through a sequence of transformations, filters or aggregations, ultimately producing a result. This approach is different from traditional looping, as stream allow us to write more concise, readable and often faster code. Now you might be wondering what makes a stream different from traditional loop. In a traditional loop, we control each step of the iteration. We tell Java how to iterate and what operation to apply to each element. But stream on the other hand focus on the result or the outcome. With streams, we focus on what to achieve rather than managing each step. This makes a stream more declarative approach, allowing us to concentrate on the goal rather than on the implementation details. Let's consider a simple example where we want to print names that starts with letter H from the list of names. In the traditional loop, we will write something like this. Let me show you. So let me create the list first. So it will be list of string names equal to arrays.asList. Let me add few names here, Harshada, then Janet, then let me add Aman and Harika. Let me save this code, and now what I will do, I will write a traditional loop. Inside that loop I will add one if condition, that if a name starts with letter H, then I will print that name. So let me write for string name colon names. So it will give me one name at a time, that is of a string data type. And now I will add one if block here, name dot starts with capital H. If name starts with capital H, then I need to print that name. Let me save this code and run. And you can see it is printing two names in the console. Now using StreamAPI, we can achieve the same result in a single line of code. Let me show you that as well. So for that, what I will do, so I will write names dot stream dot filter. What filter do? It will filter out the names which starts with capital H. So I need to write name. I will use lambda expression name dot starts with capital H. And finally I will write for each loop here, and I will add system dot out double colon operator println system. Let me correct it. Let me save this code and run for you, and you can see it is printing the same output. Let me do one more thing. Let me add partition here. So now let me save and run it again, and you can see it is printing the same output. So see how more concise and readable this approach is. Instead of managing the iteration and condition manually, stream handle the how for us. This also makes the code less error prone and easier to understand. Alright, now that we know what streams are and why they are different, now it's time to look at how to create a stream from the collection in Java. Streams can be created from various sources, but the most common source is a collection like list or a set. Let me show you how to create a stream. To create a stream, Java provides a .stream method on a collection type. So let me write a stream of string, and let me give the name stream equal to names dot stream, and it will return me the stream of object. Let me import the stream as well. This name stream can now be processed using different stream operations such as filtering, mapping or reducing. Let's do some practicals with this stream. Let's use the for each method, a commonly used terminal operation, to print each name from this list. So what I will do, I will write name stream name stream dot for each, and I will add system dot out double colon operator print ln. Let me save this code and run. So you can see it is printing all the names. Let me do one more thing. Let me add sysout statement and let me add the partition. Let me save and run it again, and you can see it is printing all the names. So here we created a stream from names and used for each method to print each element. Since for each is a terminal operation, it completes the stream pipeline and output each element directly in the console. Before we wrap up, let's discuss some of the key benefits of using Stream in Java. The Stream API provides some powerful advantages over traditional approach. One, as we have seen, Stream make code more shorter and easier to read. Instead of focusing on how to achieve each step, we focus on the goal, which result in a clear code. One of the most significant advantages of Stream is their ability to handle parallel processing with ease. By using parallel stream, Java can split a large collection into smaller parts and process them concurrently, leveraging the multi-core processor to improve performance. Let me show you that example. So first what I will do, I will create one list of integer, and it will be of numbers equal to arrays dot as list, and let me add few numbers here, 1 2 3 4 5 6 7 8 9 10. Let me save this code, and now I am going to use parallel stream on this numbers list. So numbers dot parallel stream dot, I will calculate the sum of these numbers. So I need to use reduce method, and initial value will be 0, and I use integer double colon sum. And what I need to do, I need to save the result into some variable. So let me create int sum equal to, and I will print this value sum colon plus sum. Let me save this code. So in this example, instead of processing each element in a sequence, parallel stream divides the work among available cores, potentially speeding up the large computation. Another advantage of stream is performance optimization. Java optimizes stream execution particularly for intermediate operations, which are lazy. This means they only execute when a terminal operation like for each is called. This approach minimizes unnecessary computations, making stream highly efficient. To summarize, the Stream API in Java allows us to process data more readable and concise way. By shifting our approach from traditional loop to functional and declarative style, we can make our code more easier to read and often more powerful. In our next video, we are diving deeper into intermediate operations, where we will cover powerful transformations like map, filter, flat map, and many more. Make sure to like this video if you found it helpful, and subscribe to Dev Portal so that you don't miss the upcoming videos on JavaStreams. Thanks for watching, and I will see you in the next video.